Welcome to The Explainer. Today, we're going to tackle a term you probably hear all the time, correlational research. We're going to break down how it works, and this is the big one. We'll uncover the single golden rule you absolutely need to know so you don't fall for a really common statistical trap. Okay, so to kick things off, let's start with a classic puzzle. You know, the kind that trips a lot of people up because it starts with something from the real world that at first just makes zero sense. And here it is. It's a real fact. When ice cream sales go up, crime rates go up right along with them. Seriously, you can plot it on a graph. So what in the world is going on here? I mean, does eating a scoop of ice cream suddenly give you the urge to go out and break the law? It sounds completely absurd, right? Well, that weird connection between ice cream and crime, that is the perfect way for us to jump into our topic. It's a textbook example of a statistical correlation. So to solve this little mystery, we first have to get a really good grip on what that word actually means. Let's talk about decoding the relationship score. The easiest way to think about correlational research is to see it as a kind of relationship detector. It just looks at two totally different things happening out in the world and asks a simple question. Hey, are you two connected? And if the answer is yes, it spits out a score that tells us the story of that connection. And here's the absolute key. The researcher, they're just an observer. They're hands-off. Like the definition says, they aren't in a lab, they're not tinkering with anything or trying to change the situation. They are just measuring two things that are already happening naturally out in the wild to see if they move together. So this relationship score has a name. It's called the correlation coefficient. You'll usually see it as the letter R, and it's just a simple number that lives on a scale from -1 to +1. That's it. If you get a score that's super close to +1 or -1, that means you've got a really strong, predictable relationship. And if the score is hovering down near 0, well, that just means the connection is weak, or maybe not even there at all. Okay, so let's look at the different types. First, you've got a positive correlation. This one's easy. It's when both things are moving in the same direction. As one goes up, the other one goes up too. The classic example is studying and test scores. Now, it's not a perfect guarantee, but usually the more hours you pour into studying, the higher your grade is going to be. They rise together. Then you have the flip side, negative correlation. This is where the two things move in opposite directions, kind of like a seesaw. As one side goes up, the other side comes down. Think about supply and demand. When the price of something really popular goes way up, what happens? The number of people who want to buy it, the demand, usually goes down. And of course, there's zero correlation. And this one is exactly what it sounds like. There is just no relationship to be found, none. The two things are completely independent of each other. For example, there's pretty much no link between how much money someone makes and how patient they are. The two just have nothing to do with each other. So, how do researchers actually investigate these links? I mean, if they're not in a lab coat mixing things in beakers, how do they spot these connections out in the wild? Well, they have a few main tools they use to gather the data. It really boils down to three main ways of getting the data. First, you've got surveys and questionnaires. Pretty straightforward, right? You ask a whole bunch of people the same questions and then look for patterns in the answers. Second is what's called naturalistic observation. This is where researchers just watch. They observe people or things in their natural environment without getting involved. And third is archival research. This is cool. It's kind of like being a data detective. You dig through records that already exist, stuff like census reports or historical files, looking for connections that nobody's noticed before. All right, we've talked about what correlation is and how we find it, but now we're getting to the most critical part. The major limitation of this kind of research. So I need you to really lean in for this next bit because it is, without a doubt, the golden rule of this whole explainer. Here it is. Write it down, tattoo it on your brain. Correlation does not imply causation. Let me say it again. Just because two things are connected, it does not mean one is causing the other. This is it. This is the big one. Seeing a link is only the start of the investigation. It's never, ever the final answer. So why not? Why isn't correlation causation? Well, it comes down to two big problems. The first one's called the directionality problem. Basically, even if we know A and B are linked, we have no idea if A is causing B or if B is causing A. The arrow could point either way. And the second one, this is the one that solves our ice cream mystery, is the third variable problem. This is the idea that some other hidden factor, let's call it C, could be lurking in the background, secretly causing both A and B to happen at the same time. And that brings us right back to where we started. So what's the hidden third variable connecting ice cream sales and crime rates? You guessed it, it's hot weather. Think about it. When the temperature goes up, more people buy ice cream. That's one effect. And when it's hot out, more people are just outside. They're on the streets, in parks, interacting more, which unfortunately creates more opportunities for crime. The heat causes both things to rise, but the ice cream and the crime, they have no direct causal link at all. So you might be thinking, okay, if correlation can't prove cause and effect, then what can? And that's a great question. That's where a totally different approach comes into play: experimental research. Getting the difference between these two is what separates the casual observer from a really sharp, critical thinker. This table breaks it down really nicely. Look at the goal. For correlational research, the goal is just to see if two things are related. But for an experiment, the whole point is to establish cause and effect. Now look at the variables. In a correlational study, you're just measuring things as they are. In an experiment, you actually manipulate one variable to see how it affects another. And that leads to the biggest difference: control. Experiments go to great lengths to control for all those other factors, those third variables. Correlational studies, by their nature, can't. That active control, that's the magic ingredient that lets an experiment say, yes, this causes that. So from now on, whenever you read a headline or hear a story that links two things together, like people who drink coffee live longer or owning a pet makes you happier, you'll know exactly what question to ask. You'll stop and think, wait, is this just a correlation? And more importantly, you'll start looking for the real story. What's the hidden hot weather here? Thanks for joining us on The Explainer.